Hello guys, back to another lecture, and in today's lecture we will be talking about the purification of colloids. In our previous lecture we have talked about the preparation of colloids and the different artificial methods that we can use to prepare colloid. And what we have understood from the preparation of colloids is that colloidal solution, when we try to purify that, we get two parts. One of them is purely colloidal solution and another is excess waste or electrolyte. These things are mostly electrolytes, which is plus minus. And purification is essentially known as chemical filtering, and we will be talking about three kinds of purification: dialysis, electrodialysis, and ultrafiltration. So the first one is dialysis. This is the most common method. It relies on the difference in size between ions and colloidal particles. This process of reducing impurities to the minimum desired level is called purification. And dialysis, if we try to define it, this is the process of separating the particles of the colloids from those of the crystalloids by diffusion of the mixture through a parchment paper or animal membrane. A parchment paper is a semi-permeable membrane. The impure colloidal solution is placed in a huge bag in this solution, and the bag is made of semi-permeable membrane like parchment paper or animal membrane. That is what's in our slide. So if you try to describe the process is basically, if I try to tell you the process literally, that this membrane has pores large enough for small ions and molecules to pass through, but too small for large colloidal particles to escape. So what happened is that if this is a semi-permeable membrane, small particles can pass through, but when we try to pass through colloidal particles, which are a little bigger in size, they cannot pass through the semi-permeable membrane. So this bag is now, when we have picked out the bag which is full of colloidal particles stuck because they couldn't pass through, and the other particles they have successfully passed through. So we can say that from the picture as well, we take this bag and there is the colloidal particles that couldn't go through the parchment inside, and what happens is that we try to put that in between a water flow. This is a semi-permeable. This is the bag that we've got of semi-permeable membrane, and when water flows from this to this direction, what it does is that these impurities diffuse out into water, leaving the pure colloidal solution inside the bag. When the water is flowing at a high velocity, the impurities inside the bag mixed with the particles diffuses themselves out of the bag, and the pure colloidal particles remain inside the bag. That's how you purify the colloidal solution. And if we try to see it from our slide, is that this is the process of separating the particles of the colloids from those of the crystalloids by diffusion. Crystalloids is, we all know that ionic compounds are known as crystalloids. They create positive and negative, and they're known as electrolytes. Mixture through a parchment paper or any kind of animal membrane, which is also a semi-permeable membrane. So this is the part of dialysis, and in the next part we've got electrodialysis, the high speed version of the before one. Standard dialysis is very, very slow. The dialysis that we have read till now is very slow. So if the impurities are ionic like salt, we can use electricity to hurry up the process, because in engineering speed is very important, because if you can do something at a very good speed, you are to be paid better because you have space, you have execution, faster execution. So what happens in electrodialysis, the concept is pretty simple. When we uh, so what we do is that we take two we take two electrodes in the solution. One of them is anode and another one is cathode, and these electrodes are placed in the water compartment outside the dialysis bag. We can see it from here if I try to show it. These are the electrolytes, and the electric field pulls the positive ions toward the negative electrode and the negative ions towards the positive electrode. So what happens is that one of the electrodes would be negative, which is this one, and one of them will be positive. So when we have electrolytes like KOH, one of them creates positive, one of them is negative, and when the when the water flow happens, it creates electric fields, and the electric fields, inside the electric fields, the positive ions get attracted to the negative part of the electrodes, and the negative ions get attracts to the positive part. So what happens is that in this pull, the diffusion gets much simpler and much faster, but this only works if the impurities are only electrolytes, because you need something as positive and negative in order to attract them towards the electrolytes. So that's a note. Now you gotta keep it in mind. This only works if the impurities are electrolytes. So in the next part, we have shown you a slide which is dialysis. We all know that a common term, dialysis, which is used for the purification of blood by artificial kidney, and in this method impure blood is introduced in the artificial kidney apparatus. Thus the blood is purified and the waste materials, which most probably are electrolytes, diffuse through dialyzing membrane, while colloidal blood particles are retained. These are given in the slide. You can see them, properly visualize them. And the last process is ultrafiltration, the special filter. In a normal filter, if you take a normal filter, it won't work. We need a special filter because the colloidal particle would just slip through the normal filter, because it is very this colloidal particles sit in a medium range of a suspension and a proper solution. We have talked about that in our first video, so let's not repeat that. I hope that you have watched my previous videos as well. So while talking, we have to create the special filter here. So how the special filter is created, we take the normal filter and we soak it. We soak it. I think it's disturbing because it's not connected properly. Okay, sorry for the inconvenience. So if we take a normal filter and we soak it inside a colloidal solution, which is 4% nitrocellulose in alcohol or ether, then harden it with formaldehyde. We first put it in a colloidal solution, then harden it with normal formaldehyde. What happens is that the normal filter turns into a ultra filter, and this ultra filter, the pores shrink significantly, so the liquid and ions can pass through, but a colloidal solution gets stuck on the paper. So to get your colloidal solution back, you scrap the particles of the paper and they stir them into a fresh dispersion medium again. That's how you get the purified. And if you see from the visualizations here, the definition is that this is the process of separating the particles of the colloids from those of the crystalloids by filtration through. What is ultrafilter paper? Ultrafilter paper is a paper which is obtained by treating ordinary filter paper with colloidal or gelatin solution to narrow down the pores suitably. So this was the filtration part, purification part of colloidal solution. I hope it helps, but these videos are not enough. Whatever topics that I've shown you, I've talked about them. You've got to search them, you've got to research to get more broader context. That's how you're gonna get proper concepts. If you know the basics which I have taught you here, that would also do fine. You'd be able to write with your own words. But in order to have a structured academic writing and proper usage of language, you've got to watch, you've got to research more, and it's very easy in today's world. You can just take the screenshot from my slides and give it to any AI and try and broaden up your concepts. So I think that is a very important, very, very important part. I hope you would not miss that. So that's it for today. See you in the next video.